Hey, Michael Murphy. This is Raleigh Desmond.
My name is Casey Shu.
My name is Owen Beattie.
And here we have for you our term project for open source development. So, what we've gone through and made is a lap tracker for the racing game Gran Turismo 7, but could easily be adapted for basically anything that tracks laps. We focused on making a pretty responsive and robust graphical user interface here. We use the Python framework tkinter or tkinter, whatever it is, to build our lap tracker. So as you can see, this is our landing page here that has the 6 static maps. Now, these can be added from the front end, but are not dynamic for the purposes of this. We were debating adding the functionality to add maps, but just realized that it wasn't really necessary for a project of this scope. So as you can see, when we hover over everything, we see what the name of the maps are. So if we click on one, we can see that you can enter the car, the lap time, and select player from players that are already in the system. So if we want to go through, we'll add one. We'll call the car a cheap Ford. And we're entering the lap times in seconds, just we figured that was the easiest data to work with. So it takes 400 seconds because it's a slow, cheap Ford. Then we'll choose the player. And we add the lap, which then the function then writes it to the database. And it can be seen, if we click it back up, we can see the leaderboard. We can see there that the cheap Ford is on the bottom because it's so cheap and terrible. Next, we can show you how we add a player. So the functionality is exactly the same for all 6 of the circuits, as you've seen. So then we can update a player's name, or we can just add a new player. So let's add a new one named Steve Dirt. And as you can see, then if we show all players, Steve Dirt has been added. And then if we can update players here by making his name Joe Dirt. His brother is actually the one who's playing today. So then if we exit out, we can go to show all players and see that he's been added. And if we go to a new map, if we go to one of the circuits and try to add a lap, we can see that he's been populated on the list. There's our boy, Joe. So let's get into a bit of the overall design here of the program. Our classes are pretty simple. We took an object-oriented approach just because we figured it made the most sense for interaction with the database. So we have a player class that just has an ID and a name. Then we have the lap class to create each individual lapped object, which just stores all the data, takes the player ID, which gets used as the foreign key in the database. For the laps table, we take the lap, car, everything that you just saw, etc. Now, if we get into the database itself, it's all pretty straightforward. As you can see, our boy Joe has been added. It just keeps fairly simple. All the information that we saw in the classes, but all the functions write directly from the GUI through the program through to the database. And all our data types are relatively simple. We used SQLite, so we're just taking strings and integers here. Fairly simple, but just to demonstrate the functionality of our program and everything that happens in the manager and main program. If somebody would like to talk about the
absolutely. I'll take it away with the GUI and how we decided to validate inputs. So if you were to check let's start with adding a lap. So as you can see here, for the car, we've only allowed letters, spaces, numbers, and hyphens or slashes. So if you add any other special character in there, like a semicolon or anything, or an @ sign, that's perfect either way. That won't be allowed. We can just populate a lap time with whatever. That's just an integer or a float. We need to select a player for there. Otherwise, it won't tell you specifically what you did wrong. The player needs to be selected. Sorry. So now it'll tell you that if we have a special character up there with car, it'll tell you that the car name cannot contain a special character like that. However, it can contain a hyphen or a slash. The lap time must be in the form of a float, so this will not work. It must be in the form of seconds and then milliseconds, where of course seconds can be higher than 60. It's just how we check everyone against each other is purely in seconds, point milliseconds. So that's the input validation there, and then we can see the lap that we added. I think we were in the top left, or either way. And then for adding a player, we made sure that the name added can only be in letters and can contain a space, therefore for first and last names. Yeah, so Sir Meow, he won't be let in because of that period in his name. But as soon as we get rid of that period, he'll be added just fine. And the editing, the player name is exactly the same. We can make that Prince Meow now. He's been promoted, actually. And so that's how we decided to hover or handle the. Oh, we also this menu is we need to make sure that the player name is still selected, because otherwise we wouldn't know which player we're updating. But there we go. That's been updated perfectly. And now I'm going to hand it over back to Casey.
Yeah, so my name is Casey. Sorry about that. I kind of fumbled the entries there for Owen, so my apologies for that. So I'm just going to go over the general layout of the Tinker, or Tinker, I guess is supposedly what the new kids are calling it. So I'm going to go over, this is our general class for application, which actually holds every single component of our GUI. So if we start from the top, we're declaring that this is the master, which we're initiating the default constructor. We're telling it that this is the name. It's not resizable, so we cannot maximize this window. And then center window is what we're using to actually center the windows on first launch. So if I were to actually close this and open it, it should launch directly center, and that's due to this. Menu itself is calling the images in and populating the main menu. So when we actually go in here, this would be the title tags. The self images and how we're actually populating that with the clickable images are done using photo image object method. So we're declaring that there's an array of map images and that the location is in our images folder, which is located here inside of our virtual environment Python setup. Next up is going to be the labels, which is done with a lambda event, which is then calling methods on map hover and on map click. Later on, we just break it up in components, which is this add lap, which is responsible for that add lap window, which in turn is adding in labels, which is calling functions like get average lap, get best lap, and then get all players, which is all done through our manager class. Later, then we also have the add database handle function, which is actually done through the GUI. This is due just because we want pop-up windows and everything. Obviously, we can handle this in the back end, but we decided to do the front end. That being said, we also have the call to the view all laps windows. Grab set here, just to explain, I guess I should break down each element. The transition is just a transition from the main window to the new component. Grab set is to make sure that you have the focus of that component and not the main screen. Obviously, frame is just the frame itself. Scroll bar is just an object of, or a method of the TTK or tkinter object class. And then get all laps is just a call to that. Insert update. This is just due to centering the window size, and this will center inside of the main menu. And then view all players, so forth. And the components itself kind of just repetition on that end. Then the manager class itself is just a SQL handling. So this is just the main part here and the most important thing. We're actually using a static maps list here. So we're using a list to declare the static maps. We're declaring a connection here. We're creating that connection to our database.db using SQLite 3. And then we're also doing a try exception here to make sure we're error handling, to make sure that the connection is established. If not, we will get that error through the console. Create DB is just going to create that database, and I want to make sure that the connection is established first. And the most important thing here is that we put in if not, because if not, if you don't add an if not, it's just going to create that DB and replace all data, or you're going to get an error. You'll keep getting a connection error. Load players. So let me just explain something here too. We are declaring a players array and a laps array, which in turn will create the DB after the connection is secured, and then it's going to load each player and each lap in the database. And then from that point, it's just error handling, which Owen made sure he went over and made sure that it was implemented. So you could just see here, if not, we're just simply just checking to see if those variables coming through these functions are actually handled. And most of the stuff on the bottom section, so we have the SQL portion handling the actual SQL injections. And then we just have simple array handling on the bottom end. So get average, get all laps, which is all it is in turns. So we feel like we hit every single requirement of this project. I feel like we feel as a team, and we actually learned a lot just doing this race tracking. And we figured we would actually do something that interests us as a whole. So I'll just give it to the boys just to finish it off their piece.
Hey, yeah, so I think that's a wrap for just about everything. As Casey said, we're pretty systematic about going through and making sure we got everything done that was in the requirements for the program. And as he said, yeah, really an interesting experience working in GUIs for Python, and how different it is and just how kind of straightforward these frameworks are. Owen, I don't know if you had anything you wanted to add?
Oh, just thank you very much for watching, and we hope you enjoyed our racetrack lap adder.